Welcome to the Hamilton Beach drink mixer repair. This is a common kitchen appliance and a very typical problem that you'll run into. So the customer brought this in and said it was completely dead, didn't work at high speed or low speed. We're going to take a look inside and see what we have. Okay, we've got the top of the drink mixer off now, and you can see that the line cord comes up through the bottom and is right here, one of the leads of the line cord. The other lead of the line cord comes over here and goes directly to the motor. We'll figure out which is which in a second. Now, the switch is on this other side of the top part, and that switch will move into various positions, which I'll show you on a diagram. So all we have for this thing is a switch. We're going to talk about a component called a diode that's right here. You have your motor, and you have this suspicious looking device, which we'll get into in a second. And that motor just lifts out when the whole thing screws back together. Okay, here's a diagram of really everything that's inside this drink mixer. Looking at 120 volts AC input, standard line voltage. Then there's a slide switch, and we'll talk about the positions of the slide switch. This is a schematic for a diode. This is a standard black colored rectifier diode. Symbol for a motor, and what is actually a thermal fuse that's located in between the motor and the switch. When the switch is in this position that I'm showing here, you can see that the line voltage is directly connected to that post on the switch. The switch then connects it right here, and then that voltage is directly applied to the motor. The motor, the wire from the line cord that connects directly to the motor was the neutral. So in this position we're at high speed. When I slide the switch over in the middle, that top post is open. Your line voltage, this is the black wire or the hot from the line voltage. There's a voltage, a small voltage drop across the diode, but more importantly, the diode only allows current in one direction. That's connected to the third post on the slide switch, connected over here again to the second post, which goes out to the motor. So in this position, what happens is your voltage is lowered. And it's done so because your standard line voltage is a sine wave, 170 volts peak to negative 170. And with that diode in place, the diode only allows current in one direction. So effectively the voltage across the motor then is only in one direction. In the second half, when the voltage goes low, that diode is what's called reversed biased, and it becomes open so that no current flows to the motor. Then it goes back and cycles again 60 times a second, and the output voltage, or the voltage across the motor, looks like this. So you can easily see then that the motor doesn't get as much total voltage in time, which results in it moving at about half speed. So that's a pretty simple device, a single diode used to give you two speeds. And you'll see this in vacuum cleaners, anything with two speeds. It's very likely that there's a diode in there, and I'll show you in the unit where that's at. Lastly, when we move the slide switch over to the last position, our line voltage is at the first post, but it goes nowhere. The voltage from the bottom of the diode, the cathode of the diode, is still here at the third post in the slide switch, but then it's connected to the fourth post, and that goes nowhere. So there's an open circuit there, and then this motor being connected back here is still an open circuit because this part of the switch is connected to nothing. So this is a slide switch that effectively gives you three different positions. High speed there, which is the full voltage to the motor. Half speed, kind of half speed because of the diode. And then lastly, off. Okay, lastly we'll talk about these thermal fuses. You've already studied fuses and know that they will melt a wire or they will disintegrate, or they'll break essentially when the current, or in this case the heat, is too high, and that opens up the circuit. So no matter what position your slide switch is in, you're not going to get anything to the motor if this isn't open. And this is not like a circuit breaker, which is resettable. This is gone. So once this happens, it appears that the appliance is no good forever, when in fact maybe all you need to do is replace this fuse. I want to show you how the wires are connected to the switch. Here's the switch, and here's the connections on the switch. What just came off was the connections that I had labeled on the diagram as 1 and 2, which is there's a diode in between. So if we rolled back this tape, you'd actually see a diode in between there. And I'll show you immediately how we can check to see if that diode is good.
Okay, now what we want to do is check the diode by measuring the resistance. We have a Keithley multimeter here that's set at 20K. This just happens to be a good setting for this meter to check a diode. And what we're looking for is to see what the resistance is of this diode in both directions. We know a diode allows current in one direction only. And we can check this because the meter puts out a voltage, and the diode and the meter leads are going to complete the circuit. So in one direction, measuring the voltage or measuring the resistance, we should see some resistance, and right here we're seeing about 7.2K. This is showing that some current is coming through the diode. Now we're going to reverse the test leads. When we do this, the voltage across the diode is reverse biasing the diode, and you can see that no current is flowing because we're seeing infinite resistance. And this is a good diode check. Infinite resistance in one direction, some resistance in the other direction. Okay, now we've got the meter leads connected across the fuse, and you can see that we're reading infinite, which means that the fuse is open. Well, it's pretty common that these fuses are blown in consumer appliances. Possibly the motor was stopped because it was jammed, maybe with ice cubes, or they were trying to crunch something that it couldn't crunch, and that motor started to draw current and heated up, and that's what blew the fuse. A good fuse measures 0 ohms, same as a jumper wire. We'll put the jumper wire across the fuse, and now the motor should work because 0 ohms represents what a good fuse would be. Got to do this carefully though, and make sure that whatever condition caused the blown fuse is not in place now.
Yeah, indeed, the motor came on, so we know that the problem was this thermal fuse.
Now we can take a look at the fuse that is in the drink mixer. We see that it's got a rating of 10 amps, 250 volts. Of course, we're operating at line voltage 120 volts. 10 amps indicates that the product is designed to be able to withstand quite a bit of current. We want to try to replace this fuse with another fuse that's as close as possible. As it turns out, we weren't able to find a 10 amp fuse, so we can't err on the side of pushing it higher. We've got to be cautious, and so we use less current. So we're going to end up putting in a 5 amp fuse. All of these products are designed and then tested at a place called Underwriters Laboratories, and they have to pass safety inspections at Underwriters Laboratories. So we have to be pretty sure that the fuse that's been in place here is designed by an engineer, and we want to match it as close as possible. We've received the fuse that we've ordered. This is from a company called Electronics Express. Jomex looks like it's the manufacturer of this fuse, rated at 5 amps, and we're going to put this in place, see how it does. We've got the fuse that we just bought, and we can put this in the circuit with some jumper wires and then test to see if it's going to work. It works just fine. The new fuse has been soldered in place. Now we can see if it works. Send the customer the bill.